Saxon's Calculus Lesson 64 is about velocity and acceleration, or in other words, motion for the first time, and then motion due to gravity. So part A, velocity and acceleration, has to do with the position of an object at any given time. And so when you want to find the velocity, you will derive the equation and then plug in whatever the amount of time is, and that will give you the velocity that the object is traveling. And then if you need the acceleration, you will derive it a second time. Now, I'm pretty sure every time, when you get to the second derivative, it takes you down to just a number, not... No, I take that back. Because if it was originally cube, when you derive a second time, you still will end up with a variable. But you will plug in, and then that will give you the acceleration, how fast the object is traveling at that given moment. So in example 1, they say the position of a particle moving along the x-axis at any given time, t in seconds, is given by this equation. So x at any given time is -3 t squared plus 4t plus 2. And then it wants us to find the position, the velocity, and the acceleration of that particle when time is at 3. So to find its position, we merely plug the 3 into the given equation. So that's going to give us -3, plugging in a 3 squared plus 4 times plug in the 3 plus 2. So 9 minus 3, -27 plus 12 plus 2. 14, 15, 16, 17, 18, 19, 20, 7, 8, 9, 10, 11, 12, -13. I couldn't do that a little faster. So because it is negative, that means that it is to the left. So we're going to say that after 3 seconds, this object is 13 units. Yes, they didn't give me anything. So 13 units to the left of where it started, left of origin. So that's its position. Then velocity says to derive it. So if I derive this, I get -12t plus 4. And again, we're to plug in the 3. So -12 times 3 plus 4 is going to be, just a second, I don't think that's 12. It's 6. I knew that sounded way too big. Try that again. -18. Yes, that seems a whole lot better. -14. Okay, so now since that was velocity, it is traveling to the left. Velocity. So yes, that would be 14 units per second to the left. Okay, so 14 units per second to the left of where it started. Then acceleration is derived that again. So that was this equation. So that's going to go to -6. And since that's negative, it means that our acceleration is 6 units per second squared in a negative direction. Because I don't know exactly what that is other than, in other words, it's not right or left specifically because it's velocity, it's whatever its negative velocity would be. So these would be the 3 answers that they're looking for. Example 2. The position of a particle moving along the x-axis at any given time for t is given by this equation. X sub t is t squared minus 3t plus 2. What's it want? Find the times when the particle is momentarily at rest, when the particle is moving to the right, and when the particle is moving to the left, and the times when the particle is decelerating or accelerating. Okie dokie. So we know that this equation is for our velocity. If I derive it, that gives me 2t minus 3. And then if I, then if I find the acceleration, I'm going to derive it twice, and that's going to take us to 2. So that's our acceleration. Now, if I take the derived equation and I set it equal to 0, 2t equals 3t is 3/2, then I know that it is at rest at like 1.5 seconds. And then when will it be positive? So instead of saying t equals 3/2, I'm solving for t minus 3, I'll just rewrite it. 2t minus 3 is greater than 0, which means that you're basically getting t is greater than 3/2. Then it is moving to the right, or positive. And then if you do the opposite, t will be less than 3/2. It's moving to the left, or it is the negative. All right, and then what else did it want to know? Let me go back to the original question. Find the times momentarily at rest, done. When the particle is moving to the right and left, done. The times when the particle, is decelerating or accelerating. So my second derivative was 2. That's a positive. That means it is always accelerating because it was positive. So there are the answers they're looking for. So I guess it's just looking for the acceleration and then the rest information here. Part B, motion due to gravity. So you need to have this piece of information to proceed. It's a memorized number. It's 9.8 meters per second squared. And that is going to be your acceleration due to gravity. And the other thing to make note of is that when you are above the Earth's surface, you are positive. And when you are below the